Alright, welcome back. Solving linear equations. 2 steps or more. I call this part 2, so we're going to continue building on the solving equations concepts we've already started in this course. So by the end of today I'll be able to solve equations with more than 2 steps and equations that involve the distributive property. So I'll go back over all of those things just so you can remember. So a quick review of the distributive property. We started off with using an algebra tile model of this in our class, and we had the area. This was the area. This was the dimensions. So when you have these two things multiplied together, these represent dimensions. And so when you multiply them, they're going to give you an area, and that's what we're going to model with our tiles. So let's get rid of some of that writing. So now I've set up the negative 2x down the left side, 3x minus 1 across the top side. So a negative x times an x should give us a negative x squared, and we should see we have a couple of those that we can bring in. Again, reminder that only like side lengths can touch when you use the algebra tiles, so they have to have the same length here. So we would have 6 of those. And then to fill in the last part, we would have a negative x times a negative 1, which would be a positive x. So the result of multiplying these two expressions together would be 6 negative x's. So we would write that as negative 6x squared, I should say. And then 2 positive x's. And we found that there was a shortcut to doing this. We can use the algebra tile model anytime we want, but we found that this was also a very quick way of coming up with a solution. So we would distribute that negative 2x through multiplication to each one of the terms that follow. So let's try that. So we'll start with something a little easier. So 4 times the bracket of x plus 8. So just a reminder, what that really means is that is x plus 8 4 times. That's what that truly means. But you can see already there's an awful lot of writing if we were going to try and do this. Oh, I messed up that last part here. Let's fix that one right there. Let's go x plus 8. Okay, and then if we added them, now remember there's a difference between adding and multiplying operations. So if we add these x's up, we get 4x. If we add all these 8's up, we get 8, 16, 24, 32. If we had have just used our distributive property, we could have multiplied the 4 times the x to get the 4x, and 4 times 8 to get 32. Okay, now the next one, I'm going to use the shorter method. I'm going to use the distributive property via the arrows. So I'm going to have negative 3x times 2x, and I'm just going to put a plus in there to separate those, and then negative 3x, come on, keep up with me, there we are, times negative 5. Okay, so that's the distribution of the negative 3x to both terms in the binomial. And then I'm going to multiply these out. Now this is multiplication of x's. This is not adding of x's, so this is different than the first question. So multiplication of x's is where I get an x squared. So negative 3 times 2 is negative 6. X times x is x squared. Over here I'm going to have negative 3 times negative 15, sorry, negative 5, that's positive 15, and x times, there's no other x's, so it just stays an x, and there's my answer. Okay, so now we're going to mix distributive property with solving equations. So I'm going to do this 2 different ways. The first way is I'm going to distribute, so I'm going to multiply the 3 in, and I'm going to turn this into 3x plus 6 equals 18. And from there I'm going to use my SAMDUB guide where I'm going to go after the opposite operation. So the first thing I want to do is I want to get after that positive or adding of 6. So I'm going to subtract 6 from both sides. And that leaves me with 3x equals 12. Then I'm going to go after that multiplication of 3. So I'm going to divide both sides by 3. And I get x equals 4. Okay, now I could do the exact same question a slightly different way without using the distributive property. What I am going to do is I'm going to go after this multiplication of 3 first. Okay, and this is more of an advanced technique. You really have to be comfortable with solving equations to sort of handle this. So this 3 and this 3 cancel for 1. So I'm left with x plus 2 equals 6. Okay, and now from there, I'm going to go after this adding of 2, so I'm going to subtract 2 from both sides, and then I end up with x equals 4, which shouldn't be a big surprise because I have to get the same answer regardless of the technique I use. So let's try one more. You might want to pause this and try both techniques and see which one you like better. Okay, so I'm going to use the distributive property first. So this becomes negative 7x plus 7 equals 21. Okay, from there I'm going to use my SAM-DEB techniques where I'm going to subtract 7 from both sides. Okay, these guys would cancel. Now I'm left with negative 7x equals 14. And then I'll finish this side with a dividing by negative 7 because that undoes the multiplying by negative 7. And then I'm left with x equals negative 2. Okay, if I try the second method where I'm going to divide both sides by negative 7 to start the problem, and not every problem is the same, so you have to really think these through on how the best strategy is or what the best strategy is to use. These will cancel. And now I'm left with x minus 1 equals negative 3. And if I add 1 to both sides, that will undo that subtracting of 1. I am left with x equals negative 2. And again, I got the exact same answer, which I would fully expect because it's the same question. So we have these things called wandering variables. That's what I call them. When our desired unknown is on both sides of the equal sign, we want to use the 4 operations, our add, subtract, multiply, divide, or our 0 pairs, to gather or collect them all onto one side. So that just means we have variables on both sides. It'll look something like this. Okay, so you can see here that there's 2x plus 9 equals x plus 5. There's 2 values of x, one on each side of the equal sign. So what I want to do is I want to try and use all of my opposite operations to cancel these things. So I'm going to use SAM-DEB in this case, so that's going to be my guide. So I'm going to try and go after those positive 9 ones first. So to get rid of those, I need to introduce 9 negative to both sides. And what that looks like algebraically over here is I would have to subtract 9 from both sides. Okay, so that turns into 2x equals x minus 4. So what I have is all of these terms right here, they all get highlighted and they disappear. Okay, down here I can take 5. I won't be able to separate these quite as easily because the way I set it up, but that's all right. We could follow. I can take, let's better use blue. These 5 here will cancel these 5 negatives. So you can see I'm left with 4 negatives on the right hand side. I still have x's on both sides, so all I'm going to use now is I'm going to subtract an x from both sides. So I will subtract an x from both sides. Okay, and what that looks like algebraically, I will subtract an x from both sides. Okay, and now my new expression, 2x's minus 1x, leaves me with an x. X minus x is 0, so these guys have zeroed out. These guys have zeroed out. The only thing that I have left is an x and these 4 negative ones, so x equals negative 4. Now you can see we wouldn't want to do this with tiles every single time. It gets a bit tedious to draw and move all that around, but all of the SAM-DEB operations we've been using still apply. Let's jump back to the screen we're supposed to be on. There we are. Okay, so let's try solving the following. If you want to pause it here and try it yourself, that would be a good idea. Okay, so now I'm going to give it a shot. I'm just going to make it a little bit bigger to make it a little easier to see. So I want all of my x's on one side and all of the whole numbers on the other side. It doesn't matter what side you get them on. It doesn't even matter what you start with. You've got a lot of flexibility. So I like to go after these whole numbers first. So I'm just going to subtract 11 from both sides. And that leaves me with 4x equals 2x minus 6. Okay, and now I want to go after this 2x. It's a positive 2x, so to cancel a positive 2x, I need to subtract 2x from both sides. And please write these in. It's super, super important to show the sign and the operation that's canceling it. Most people's silly mistakes happen because they don't write that in. So if you can just train yourself, write that step in, it makes a huge, huge difference. I will cancel these guys here. And now I'm left with 4x minus 2x. That's just 2x. The 2x and the negative 2x have canceled, so I have negative 6 left on this side. And then the only thing I have left to do is I have to deal with this multiplication of 2. So I'm going to divide both sides by 2. And I'm left with x equals negative 3. Okay, we'll get to, whoops, jumping around here. Almost done here, second last question, so I'll make this a little bit bigger as well. If you want to try this one first, that wouldn't be a bad idea. So you can pause it here and I'll wait for you. Okay, so hopefully you've had a chance to try it. So now again, I'm going to go after, let's go after the x's this time. So I'm going to subtract 2x this time. Doesn't matter where I start. These guys would cancel, so my new line would be 8x minus 2x. That would be 6x. So notice with adding, subtracting, that exponent is not changing. That's really, really important to remember. Okay, keep the sign on the 10. Okay, even though it was a subtraction above, you can write it as a negative sign. Those are equivalent, so we want to make sure we keep track of that sign. I want to go after this adding of 14 next, so I'm going to subtract 14 from both sides. Okay, these guys would cancel. I'm now left with 6x equals negative 24. And then my last step is divide away that multiplication by 6. And I'm left with x equals negative 4. Okay, let's try a really scary one to finish this off. This is our last question, so pause it here and give it a whirl. I'm going to make it a little bit bigger before I start, so you can do this a bunch of ways. I'm going to start with distributive property because I don't like the brackets. This is just, you develop your own style after a while. I find this works best for me. So I'm going to distribute that in, so I end up with 8x plus 20 equals 2x minus 40. So you'll notice this looks very similar to the previous question. It just had one extra step, which was the distributive property. So now I'm going to subtract 2x from both sides, subtract 2x from both sides, those cancel. I'm now left with 6x plus 20 equals negative 40. Again, keeping an eye on that sign, you don't want to lose it. I then want to subtract away this adding of 20. Okay, those cancel. That's my goal. I'm trying to get this x by itself or isolate it. Remember, that's the key word. So now negative 40 minus 20 is negative 60. And then my last step is I'm going to divide both sides by 6. And I end up with x equals negative 10. And there's my answer. Okay, and then grade 9 academic, page 220, a couple of questions to try. And thanks for tuning in.